Hello and welcome to another video, this time going through question 10 on the 2018 Mechanics A2 paper, and it's a projectiles question. Okay, first thing I'm going to say, when I do projectiles questions, I write everything as vectors, but if you just take the top of my vector as the horizontal equations and the bottom of my vector as the vertical components of speed, acceleration, etc., you'll have exactly the same working as me. I honestly prefer to use vectors. I can just see everything in it, but that's just me. Okay, so what do we got here? A boy throws a ball at a target. Here's the target, I guess. At the instant when the ball is in the hand, it's 2 meters above the ground. Its highest point is reached when 3 meters above the ground, so that's when the velocity is 0. Remember, it's always at peak when the vertical component of the velocity, anyway, is at 0. It's changing sign because the vertical component's positive here, then it's 0, then it's negative. And really, everything's on the diagram here for us. So if we're going to show that u squared is 2g over sine squared alpha, well, what I'm going to do first is I'm going to write out everything I've got. I'm going to write the vector u would be, in other words, the initial velocity vector would be u cos alpha and u sine alpha. And that's because you can make this into a little triangle. And clearly, the capital U is on the hypotenuse, so that's u cos alpha and that's u sine alpha. Hopefully that's nice and clear. A is always, if you do it in this way, 0 minus g. What's more, we know, we've got to in some way use this. We do know that the velocity is, well, I could write this as Vx. I do actually know it because the velocity will just be ut cos alpha just because the acceleration component is 0 here. But I'm just going to write it as Vx. I actually know that I can work that out and it's just going to be ut cos alpha. But I'll just write Vx here. But Vy is going to be 0 provided S equals... now, what have we got here? I don't know the horizontal component, so let's just call it s little x. That's how I normally do these, but I know the vertical component is going to be not 3 but 1, and that's because we're 1 meter above where we started. When you do these equations, this is like your origin, where you start, and so everything's in relation to where you start. Okay, using that, I just scan these now and think, okay, well, that's kind of good because I've got the bottom elements for each one of these. So I should be able to come up with, and also it's got a U, it's got a sine alpha in it. It looks like it's got a G in it. It looks like the right ones to use. So I'm going to use V squared equals U squared plus 2AS. Now I'm going to use the Y components. And that's going to give me 0 equals u, capital U that is, u squared sine squared alpha plus 2 times by minus g times by 1. And so we get minus 2g there, and I can add it over here. So I get 2g is u squared sine squared alpha. And so the result follows. U squared is 2g over sine squared alpha. Done. Okay, that's part A done. Part B looks a lot more challenging because we've got to find the size of angle alpha, and I'm really saying it's challenging because it's worth 9 marks. But it does give us some more information here. It tells us it's a distance of 20 meters horizontally, t. That's clearly very useful. And it's 0.75 meters above the ground, which means it's minus 1.25 below where it started, and that's what I'm going to need to use. So, okay, once again, I'm just going to write down everything I know. U is u cos alpha, u sine alpha. Now, V, I don't know V here. I do know A is 0 minus g. That's always a nice one to write down. I also know the displacement here because the displacement is going to be 20 across and then minus 1.25 down. Yeah. And I'm just going to write down t equals t. Yeah. Clearly, I've got to use this because I used this information already, so I've got to use something fresh, something new. Okay, so here's my strategy. Firstly, I'm going to write down, well, if I use s equals ut plus a half at squared this time, And I hope you can see why I'm doing that. It's because I've got yes, u, a, and t. That's the Suvat equation I'm going to be using, but I'm going to be using the horizontal components this time. So I get ut cos alpha. And remember, I know what capital U is now, really, in terms of sine alpha anyway. But ut cos alpha minus g over 2 t squared, well, that should equal 20. Yeah? Okay, that's interesting. Trouble with this is I've got a t and I've got an alpha which is still unknown. Yeah, which is slightly disappointing. That's a little bit. Oh, hang on, I've realised I've made a blunder. Can you see my blunder? Look, I've used ut cos alpha and then I've used minus g here. I should be using 0. Yeah, so sorry, I should just have ut cos alpha is 20 because I'm going to have ut cos alpha, and I'm going to have plus a half times 0 times by t squared. So that's great. I can actually write down them. Let's move it across a bit. Ut cos alpha is 20. Yeah, that kind of looks good, but still two unknowns, t and alpha. So I'm going to have to use the other one. I'm going to have to say minus 1.25 equals, right, ut sine alpha minus g over 2 t squared. Yeah, so I get a quadratic here of g over 2t squared minus ut sine alpha minus 1.25 equals 0. Yeah, so I've got two equations, two unknowns. Yeah, now my thinking is, well, if I can use this in some way, it would be really handy. Like if I could in some way employ both of these at the same time. Remember as well that I've still got this result up here that it's possible I might need to use as well. My thinking though is I need to get rid of the t so I can find the alpha. So I'm going to try and get rid of the t here by rewriting. If I call this one a and this one b, can I rewrite a as t equals 20 over u cos alpha? Because then I can plug it in here, and I'm going to get g over 2 times by 400 over u squared cos squared alpha minus ut, well, that's just 20 over cos alpha times sine alpha, because ut is just 20 over cos alpha times by sine alpha, so there's your tan alpha, minus 1.25 equals 0. Yeah. Now, this is quite hard, this bit, but can you see that we've got 200g, because the 2 is going to cancel and make that 200, over, well, this is like sec squared, isn't it? Like, it's just making me think, I really want to write this as sec squared, because then I can write sec squared as 1 plus tan squared, and then I've got it all in terms of tan, which kind of looks nice. So I'm going to call that 200g over u squared multiplied by sec squared alpha minus 20 tan alpha, thinking, minus 1.25 equals 0. And so as 1 plus tan squared alpha is sec squared alpha, I can write this as 200g over u squared. I think I might actually write down u squared though as 2g sine squared alpha, because or 200. Yeah, in fact, it might be better if I do this right. Yeah, just deciding the quickest way of doing this, because I can see that I don't want the u squared in there. Obviously, I want this. I want this eliminated. I want everything solely in terms of tan alpha. That would be ideal. So if I rewrote, I'll tell you what. I'll do this slowly. I'm going to leave this as, because I'm just suddenly thinking u squared is 2g over sine squared. So I get cos squared over sine squared, but it's something divided by that. So that will eventually turn into a tan squared. That's my kind of thinking here. So we'll keep the 200g there, but then the u squared we'll write as 2g over sine squared alpha multiplied by cos squared alpha. Let's not turn that into sec squared. That was a bad idea. Well, it just didn't. It's not that it was a bad idea. It just didn't seem to be getting me to where I want to be as quickly as I would have liked to have been getting there. So let me just move that across. So hopefully you can see where I'm coming from here. So we get 20 tan alpha here, minus 1.25 equals 0. And so look at this. The G's look like they're going to cancel here because 200G, well, you know, there's lots of ways that you can think of this as 200G over 2G cot squared alpha minus 20 tan alpha minus 1.25 equals 0. And of course, the 200 over 20 is just 100. The G's cancel, and 100 divided by cot squared alpha is the same as 100 tan squared alpha. So you get 100 tan squared alpha here, minus 20 tan alpha, minus 1.25 equals 0. Yeah, let t equal tan alpha, and it will be a little bit easier to see. You've got 100t squared minus 20t minus 1.25 equals 0. In this kind of question, when you're stressed out, it's probably best to just use the quadratic solver on your calculator. It may well factorize, but yeah, I don't think I'd be sitting there thinking I want to factorize this in the exam. So I think I'd probably just want to get on with it and get the final answer. So let me just quickly type this into the equation solver on my calculator. Polynomial order 2. So I've got 100, and I probably should have cancelled this, minus 20 and minus 1.25. Okay, I'm getting a quarter, and that's it. It's a perfect square. So tan alpha equals a quarter according to my calculator. So then we're just got to do inverse tan of a quarter. Inverse tan of 0.25. We get 14 degrees. There we go. We've found it. To two significant figures, it's 14 degrees. Part C, state one limitation of the model. Okay, you could do wind resistance here, like that seems, you know, because wind resistance has been ignored, so that's a limitation. Sometimes they say give one reason other than air resistance, you know, to try and keep you on your toes. In which case, say something like the spin of the ball, or you know, the fact that the ball's going to go, you know, like left and right, not necessarily just up and down, if you see what I mean. But yeah, probably the spin of the ball is probably the best one to do there. And the last question, what do we got? Find the time taken for the ball to travel from A to T. So it's going from A to T. Okay, well, we've just found tan alpha. We've got to find T. Now, I think we still have this equation up here. Yeah. We had G over 2 T squared minus UT sine alpha minus 1.25 equals 0. Yeah. Now, U sine alpha, from this one, you can see that U sine alpha, if you take that over there, it's just going to be root 2g. Yeah. Take that over there and square root both sides. You're going to get U sine alpha is root 2g. So what I can do is call that root 2gt. Minus 1.25 equals 0. Then I could just solve the quadratic once again using the quadratic solver function on my calculator, which I think I'll use. Polynomial order 2. So what we got, 4.9 there for the coefficient of t squared, and then minus the square root of 2 times 9.8, and then the last one is minus 1.25. Okay, I'm getting a time of 1.13 seconds. And you are allowed to just say, you know, by calc, I've solved this. T equals 1.13 seconds. The other value of t you get is negative, and so you can ignore that. And that's the whole question. Hope you found the video useful. Keep up the hard work, and I'll see you soon. Bye-bye.